Okay, so let's do a stoichiometry problem. How many milliliters of a 0.5 molar solution of hydrobromic acid would be needed to react completely with 5.6 grams of magnesium hydroxide? Well, first off, we have to write out the chemical formulas for these two reactants, predict the products, and balance out the reaction then. So magnesium hydroxide plus hydrobromic acid. This will give us this is a double displacement reaction, or you can think of it as an acid-base neutralization reaction. Anyway, the products is going to be water plus magnesium bromide. Okay, so now we're going to balance our reaction. And we're going to produce 2 moles of water. And we're going to use up 2 moles of hydrobromic acid. So now let's get to the stoichiometry calculations. So starting off with 5.6 grams of magnesium hydroxide, and we need to turn this into moles of magnesium hydroxide. And to do that, we have to divide it by its molecular weight. So magnesium hydroxide grams is going to be in the denominator here, so we can cancel out the 5.6 grams of magnesium hydroxide in the numerator of the first expression. So doing this, we get 0.096 moles of magnesium hydroxide. So now that we know our moles of magnesium hydroxide, we need to convert it to moles of hydrobromic acid. So that is why we need to always balance our equation, because we know now that for every 1 mole of magnesium hydroxide, we are going to need 2 moles of hydrobromic acid. Again, 1 mole of magnesium hydroxide here is in the denominator because we need to cancel out the unit of moles of magnesium hydroxide in that first equation, in that first expression. So doing this, we get our answer now in terms of moles of hydrobromic acid, which is 0.192 moles of hydrobromic acid. So we need to get this into liters of hydrobromic acid, so we will be using the molarity as our conversion. And knowing that 0.45 moles of hydrobromic acid is equal to 1 liter of hydrobromic acid. So this is basically molarity of hydrobromic acid flipped, or the reciprocal. And by doing this, we get our answer now in liters of hydrobromic acid solution, which is 0.426 liters of hydrobromic acid solution. But we need our answer to be in milliliters. So we will take our liters, 0.426, and we know that there's going to be 1,000 milliliters per 1 liter. So doing that conversion, our answer then is 426 milliliters of hydrobromic acid solution is needed. And this is our answer.